from this slide onward, now this figure that we have over here, it shows the top level format for an ESP packet. Now if you look, it has this fields, like what are the fields present in ESP packet. So first field is SPI 32-bit, its length is 32-bit, which is used to uniquely identify a security association. Then we have sequence number. Length of sequence number is again 32-bit, and this sequence number is monotonically increasing counter value. Like every time a new packet is generated, a new sequence number is created for it. And the purpose of this sequence number field here is to prevent replay attack. Okay. And then we have payload data. Payload data can have a variable length. There is no fixed length for it, but it should be multiple of 32-bit overall these field: payload, pad length, and next header. So if it is not multiple of 32-bit, we have to add some padding bits over here. So we can add maximum 0 to 255 bytes of padding bits, bytes over here or bits over here. And here we have to specify in this field pad length, how many padding bits are there, not bits, bytes, padding length. We have to specify how many padding bytes we have added over here. So pad length for it. Next header, okay, pad length is 8-bit. Next header also 8-bit. So next header, identify the type of data that is there in the payload. Like you can have a next header can be extension header for IP version 6 or TCP or UDP header. What is the next header after this? Okay, and then we have integrity check value. As we know that ESP provide both encryption and authentication. So if we are doing encryption, so which fields are encrypted over here? So which fields are encrypted over here? If we can see that sequence number and SPI is not included in encryption. Encryption start from payload data up to next header. Okay, and if we want authentication, then integrity check value is present over there. Otherwise it's 0, all 0. So integrity check value is not having any fixed length. It is a variable length depending on which algorithm you use to calculate the MAC, and it contain ICV or MAC over the ESP packet minus authentication data field, because when we are calculating MAC on it, this ICV field is not included in MAC calculation. So ICV coverage is, or everything is like SPI sequence number up to next header, all fields are covered in integrity check value or MAC calculation. Okay, here if you see this, we can add, as we know that one of the service that is provided by IPSec is limited traffic flow confidentiality. Now traffic flow confidentiality is that we don't want attacker to know the length of the messages. Okay, and we don't want to know more detail about the packet, like what kind of data is there. So we encrypt it, and length is also can be hidden from the attacker by adding here traffic flow confidentiality padding. Okay, this new thing, it is not over here. After your payload data, you can add this field traffic flow confidentiality padding before the normal padding, just to change the length of the packet. Okay, and other things are same. What is the coverage in ICV and encryption? Same thing is explained over here in these slides, which I already tells you. Okay, what is the purpose of this padding field? One purpose is, if you are using an encryption algorithm like plain text, where we have a block, we want to create a block, so padding field is used to expand the plain text to the required block length. Another purpose of it is used to assure alignment of pad length and next header field. And if you add additional padding, it also add partial traffic flow confidentiality by hiding or concealing the actual length of payload. Okay, this anti-replay mechanism, yes, this is important here. Now IPSec protocol provide you prevention from replay attack. Okay, and you know what is a replay attack? When attacker obtain a copy of an authenticated packet and later transmit it to the destination. So if destination can find out that this is a duplicate packet, it is the packet which I already received, then there is no chance of replay attack. So in order to prevent replay attack, sequence number field is used. And when we use sequence number field, so as I told you that when a new security association is established, sender initialize sequence number counter to 0, and each time a packet is sent on this security association, sender increment it by 1 and place that value in the sequence number field. And when it reaches to 2 raised to the power 32 minus 1, we do not take it back to 0, but we discard it. We terminate that connection and create a new one. Okay. Now what is this anti-replay mechanism? Now we know that IP is connectionless and unreliable. Unreliable means that if your packet is not reached to destination, you will not get any negative acknowledgement, or sender will never come to know that packet has not reached to destination. So it does not guarantee the delivery of packet in order, or even it does not guarantee at all that packet will be delivered. So IPSec try to resolve this problem. So for this purpose, on the receiver side, this is receiver side. On receiver side, you receiver implement a window of size W. Okay, this is window, you know this thing, and size of this window is W. W is mostly initialized with value 64. Okay, we have two edge of this window, right and left edge. So right edge of this is the right edge. Okay, right edge of the window represents the highest sequence number n, so for received for a valid packet. So whenever a valid packet is received, if it does not lies into this window, it is like, okay, this I'll discuss later on. Okay, right edge is on the highest sequence number, so for received for a valid packet, and left side is representing here n minus W. Okay, all the packets that are over there minus the width of the window, which is we already window size we already fixed to 64 normally W. So any packet which are in this window are considered to be a valid packet and is accepted. Any packet when it is received by receiver, if it lies within the window, how we come to know that it lies within the window? If its sequence number is in the range of n minus W plus 1, this is plus 1, n minus W plus 1 up to n minus W plus 1 up to n. If a packet lies in this range, it is received a valid packet and receiver will accept it. Okay, so what happened when a new packet is received by receiver? How this window moves? Okay, I will tell you how windows move. So let's suppose a receiver receive a packet. If packet is falling within the window, like the sequence number of the packet is between n minus W plus 1 up to n, any number in between them, and MAC, then receiver will authenticate that packet. Okay, its MAC will be checked. If packet is authenticated, then that slot in window is marked. Okay, like here, marked if valid packet receive. Okay, we will mark it or we fill it. Okay, we have received this packet. Okay, second case, if the received packet is to the right of the window. It lies outside the window. Like here, you receive a packet and packet is having a sequence number which is somewhere over here. So it is not inside the window. It is on the right side of the window. So now what you will do, you will have to check the MAC of the packet. If MAC of the packet is authenticated, then what you will do, you will move this window forward and put it on the edge where this new packet lies. Like if this new packet lies over here, we will move this window until here, like this, you know. Okay, let me show. I can't see my cursor. Okay, sorry. Now I don't know where is my cursor. Cursor is back. So if it is over here, so you will move this window. How many? 1 2 3. So 1 2 3, your window will move like this. This will be our new window. If a packet lies on the right side of the window, if the sequence number is over here, so you check it is properly authenticated, so you move window forward, okay, and mark this packet as a received packet, and now window has moved forward. And if you receive a packet that lies anywhere over here on the left side of the window, then that packet is simply discarded. Okay, it will not be accepted by the receiver. So the mechanism is same that is used by TCP. If you remember TCP sliding window protocol, it works on the same rule. Any question?
Thank you. No, doctor.
Okay, this is just showing transport and tunnel mode. Like always keep this in mind. You can have a transport mode between two hosts only. Normal hosts, not a gateway or routers or firewalls. Transport mode is only present, or you can create a transport or choose transport mode. Where to choose transport mode? If both end of this connection are normal host, okay. And this show a tunnel mode, a virtual private network via tunnel mode. In tunnel mode, okay, tunnel mode you can create between normal hosts as well. It's not like if you have two hosts you can always have a transport mode. You can have a tunnel mode as well, but tunnel mode will not give you any advantage. Even if you choose tunnel mode, there is no advantage of it. So we don't use tunnel mode, we use transport mode. But tunnel mode is used when one of the host, like here we show 4 networks, and between these 4 networks we choose tunnel mode. Tunnel mode when IPSec on one end is gateway and other end is also gateway, or when on one end of IPSec there is a host and other end is gateway. Okay, tunnel mode, when tunnel mode should choose when one end is at least a gateway. Okay, scope of ESP encryption and authentication. Yes, this is important. Now let's suppose we have either a IP version 4 packet or IP version 6 packet. So if IP version 4 packet, we have original IP header, then after that you will have TCP or UDP header and data. And if it is IP version 6, then you have original IP header, then extension headers also in IP version 6, and then TCP and data. Okay, now in this case we show how can we use ESP in transport mode. Okay, in case of IP version 6 and IP version 4. In IP version 4, if we are using ESP in transport mode, ESP header is inserted between original IP header and TCP header. And in case of IP version 6, ESP header is inserted between this extension header and your original rest of the data, whatever ESP header is there, except destination header. If we have destination header here, so ESP header is inserted between them. Okay, which fields are covered in encryption and which field are covered in authentication? We already have seen previously. If it is a transport mode, this is transport mode. So which fields are covered in encryption? This is encrypted. Okay. When we are using ESP, we are not having header, but also we have what? Trailer and authentication. What is trailer and what is authentication? ESP authentication is your ICV, which you have seen, here. Here. This is what? ESP trailer. This is ESP trailer, out of which this is ESP authentication and this is what? ESP trailer. Two things. This is ESP trailer and this is ESP authentication. So if we show it over here, this ESP trailer and ESP authentication. So for encryption, TCP up to ECP trailer, and authentication ESP header up to like authentication. ESP authentication is not part of authentication, and same is for IP version 6 header. Okay, if we are using ESP in tunnel mode, okay, how can I show it? Okay, this is ESP in tunnel mode. So in tunnel mode, you encapsulate this original packet into a new packet, so it have a new IP header over here. This is your original IP header and this is new IP header. ESP header is inserted between the new IP header and original IP header. So now which fields are encrypted and which are authenticated? So in tunnel mode, all original packet is encrypted, including your header. Everything is encrypted. And what is authenticated? Up to here. New IP header is not added into authentication, but original IP header is also authenticated. So if you are using tunnel mode, your original IP header is encrypted as well as authenticated. Okay. Any question? Okay, here we show that how ESP works. Like when receiver receive a packet, it looks like this. This is okay. This shows transport mode or tunnel mode here. Transport mode, it is written over here, huh? So this is transport mode. Receiver receive the packet. When it's sent to the IP, what should receiver do? Receiver trim. When packet moves from lower layer to upper layer, every layer remove the header. Okay, and when it moves from upper layer to down, every layer add the header. Like if I see, this is data on application layer. When it moves to transport layer, TCP header is added. When it moves to IP layer, IP header is added. Okay, when it moves to IPSec on the network layer, so ESP header is inserted between original IP header and TCP header along with ESP trailer and authentication. And in case of tunnel mode, it works like this. Original data, okay, TCP header on TCP layer, IP layer, IP original IP header, IPSec layer, ESP header, and then again IP new IP header is added over here because this original IP packet is encapsulated into a new packet. Okay, combining security associations. Yes, it is possible that on one security association, as we know that we can have either AH or ESP protocol, but you cannot have both protocol on the same security association. But we can create security association bundles. Now, what is a security association bundle? The term security association bundle, this refer to a sequence of security association, yani more than one security association through which traffic must be processed to provide a desired set of IPSec services. So the term security, association in a bundle, we can say that if you have a security association bundle, it doesn't mean that bundle only created between same source and destination. They may terminate at different endpoints or maybe at the same. So you can create bundle between two same, like two hosts, and you can create a multiple security association between them. That will be a security association bundle. One is using AH, another one is using ESP, another one is using AH in tunnel mode, one is using ESP in transport mode. Okay, so your bundle may terminate at the same point, or it is possible that the between the hosts there are gateways. So gateway creates its own security association bundle, so they may terminate at different endpoints. Okay, we combine the security association into bundles in two ways. What one is called transport adjacency and other is called iterated tunneling. Okay, transport adjacency means when we are applying more than one security protocol to the same IP packet without invoking tunneling. And we don't want to use tunnel mode, we only are using transport mode, and we are using AH in transport mode and ESP in transport mode. Okay, so but they said that this approach allow only for one level of combination, because further nesting will not produce any added benefit, since the processing is performed at one IPsec instance, that is destination. So destination for both is same. So they said that if you are using transport adjacency, one level of nesting is enough. ASP, ESP AH, or AH and ESP in any way, but don't go for more. Okay, iterated tunneling. In iterating tunneling case, we apply multiple layer of security protocol that is going through IP tunneling, and if we are using iterated tunneling, then you can have multiple levels of nesting. Okay, in AH, in transport adjacency, no multiple level of nesting, but in iterate tunneling you can have as many level of nesting as you want. Why? Because each tunnel can originate or terminate at different IPsec site along the path from source to destination, and you can combine both. You can have transport adjacency and iterate tunneling both combined by having transport security association between hosts travel part of the way through a tunnel security association between security gateways. Yani between host you have transport, and these hosts are connecting through the same gateway, and between those gateway you have a tunnel, iterated tunneling. Like, okay, where is it? Yes, like this. Between the host we have one or more security association, and then between the gateway you have a tunnel, like this. Okay. ESP with authentication option.
Excuse me, doctor.
Yes.
Still not clear what is the benefit of bundling, or what is bundling exactly?
Bundling mean like you want to use encryption and authentication together, like we are going to discuss now here. One option is you can use ESP only. ESP provide you authentication and encryption both.
Yes.
Fine, but you want that I want to use authentication, but I want to authenticate my IP header as well, because if we are using ESP for authentication, it will not authenticate any of the field of IP header, and you want to authenticate IP header as well. So for that purpose you can use AH. So now you choose that, okay, I want to use AH for authentication and ESP for encryption. I am not interested to use ESP authentication option, but I like AH more. I want to use AH as an authentication and ESP as an encryption. Then what you can do is you can create two security association between same source and destination, or between same hosts. One is using AH in ESP mode, transport mode, and other one is using ESP in transport mode. So this we create a bundle, two security association, more than one security association when you are using, that is called a bundle. Like here definition, a sequence of security association through which traffic must be processed to provide a desired set of IPsec service. Okay, let me go through this example. Like this is an example of one of the transport adjacency. Transport adjacency and iterative
So,
tunneling. Okay, this is transport adjacency example. What it is? Now what we do is, first we, this is our original packet. Okay, we inserted ESP header over here between original IP header and TCP header, and ESP trailer we add into it. So we took ESP for encryption, and then we want to use AH for authentication. So AH is applied after that. So now where AH header will be inserted, AH header will be inserted over here between original IP header and ESP header. Now if you look at this packet is representing transport adjacency. Why we call it transport adjacency? Because it is having more than one IPsec protocol implemented on this packet. One is AH and another one is ESP. Got it? Let me complete it, so maybe you will get idea more.
okay.
ESP with authentication option. If we are using ESP along with authentication, we can use it in transport mode or tunnel mode. If we are using it in transport mode, then authentication and encryption both apply on payload, but not on the header. Header is not protected. If we are using tunnel mode, then our header is protected. Okay, authentication apply to entire IP packet delivered to the outer IP destination, and authentication is performed at that destination. So like I gave you an example, if I ask you, I want to authenticate my header fields along with payload, so which IPsec protocol and which mode is appropriate for it? Okay, so one option you can choose is, you can use ESP in tunnel mode. ESP in transport mode is not a option, because header is not authenticated at all. One solution is use ESP in tunnel mode, or the other option is, if you want to use transport mode, then you have to go for transport adjacency. Use ESP in transport mode for encryption and AH in transport mode for authentication. Did you get the idea?
I mean, we get what are you saying, but I'm trying to imagine it physically. So what is it? Is it like I encapsulate, for example, AH package with ESP package, or is it like I am establishing multiple SA channels, and then the question would be how those channels would be
You have to
related.
You have to create multiple essays, because on one essay you cannot combine AH and ESP both. This is for sure.
No, not in one. See the package that we've seen. The next slides, as if it was like encapsulated, the AH package, the ASP package here, as if it was like encapsulated within the AH package.
For AH, this become a payload now.
Yeah. So how this encapsulation happened?
It's not an encapsulation. For AH, this is a payload and AH header is inserted over here. But if I change the order, ESP here and AH over here, then things will be different.
So then the AH packet would be encapsulated, would be a packet of ASP, so to
Now,
speak.
if this is the case, okay. Question is, which fields are encrypted? Tell me which fields are encrypted. We perform
No,
encryption over here.
yeah,
Which fields are encrypted?
from TCP up to yes to the data
Yeah, maybe
to the
from
data.
here we can say.
Yeah, from the TCP.
Yeah, yes. Okay. And okay. So this is encrypted. Okay. What is authenticated now?
Uh, Maybe authentication wasn't used in the second.
All. Here
Yeah.
ESP is without authentication. So
Yes,
nothing
without
is
authentication.
authenticated. Okay.
Yes.
Now we apply AH. When we apply AH, which fields are authenticated? All fields are
All
authenticated, even original IP header, except mutable fields. Except mutable
mutable.
fields here. Okay, we can write here except original IP header, mutable fields, all fields are authenticated. Okay, if I change now, just
So now, how is my question again? Um, let's mean somehow I've been able to create the ASP packet and then give it to to a security association that has AH, right? How physically is implemented?
you will have two entries in security association database for it. It will be two security association. This has its
Uh-huh.
own security association, this have its own security association. It's
So how those are related then? There is a definition for bundle maybe in the record
But
to relate.
bundle mean when you are applying more than one ESP packet on ESP processing on same packet.
So
This
how to
this packet
define
is
it?
same. This packet is same. This TCP and data same. But we are applying
Yeah.
one security association or one IPSec processing through this and one IPSec processing through this.
Yeah. So my question would be, if I can rephrase it, how to really define it? How to define it in the records? It will be there extra
Okay,
fields that
security
define.
association database create
Yeah.
have entry SPI. Now SPI for this is different and this is different. Destination
Yes.
address will be same because we are using transport adjacency. So when we are using transport adjacency, both are having same destination IP. When any receiver receive it,
Okay.
that will be same, but SPI will be different and will have protocol ID also different. For one security association, protocol ID is AH, for another one it will be ESP, and both will
Yes.
use their own keys, own
Yes.
algorithm. Okay, let me just original IP header, and this is your TCP and data. If I just change the order, then what happened? Okay, data and trailer or whatever.
Okay. Let's say payload.
Okay, now which fields are encrypted and which are authenticated? I will
Now,
ask like this in exam, huh? Look at
so
it.
now authentication.
First authentication, then encryption.
Authentication is from TCP up to the data, and encryption is also the authentication included in the encryption.
Think about it. Here I was. Okay, ESP. So we can use tunnel mode also. So tunnel mode I already described for you. Okay, in both cases, in ESP, authentication applied to the ciphertext rather than on the plain text. Keep this in mind. If we are using ESP for authentication, first we perform encryption and then authentication, and they said this is good. Although when we were discussing, public key cryptography, we assume that we should perform signature on first encrypt and then authenticate, or first authenticate then encrypt, which is better option. We discussed these things, but here in this case they said that first encrypt then authenticate, and by doing this they said that the chance of denial of service attack become very low. It prevent DOS attacks if we first encrypt and then authenticate. Okay. How? Nobody asked.
Hmm?
Okay, fine. Transport adjacency. Now another way to combine this both authentication and encryption. One way is this, only ESP. Another way is transport adjacency, that is this way. So in this way we are applying again, we are doing authentication after encryption. We perform authentication on encrypted data in transport adjacency. But if we are doing transport tunnel bundle and we want to use authentication before encryption, then they said the one that I draw is not a good option. The one that I draw here, like first AH and then ESP, that is not a good option. You should go for this transport tunnel bundle. Okay, and why we want, like, okay, if authentication before encryption, the reason for it is impossible for anyone to intercept the message and alter the authentication data without detection. Why? Because in order to make changes into the data, it has to decrypt it first. Okay, because we perform authentication first and then encrypt. So in order to change authentication data, it has to decrypt it. For decryption it needs key, and if he doesn't have a key, he cannot decrypt it. Another reason this why we want authentication before encryption, because it is desirable to store authentication information with the message at the destination for later reference. Like later on, if we want to authenticate data, if we perform authentication on encrypted data, it means then every time when we want to verify this data later on, we have to first encrypt it and then authenticate it. So we have to use or keep record of or manage two keys, which is not a good thing. So they said that now it's up to you whether you want to use authentication then encryption or encryption then authentication. Okay, so if we want to use authentication before encryption, one approach is to use a bundle consisting of an inner AH transport assay and outer ESP tunnel assay. Inner is transport and outer is tunnel, like this. Inner is transport AH. This is apply AH in transport mode. This is original packet. We apply AH in transport mode. We inserted AH header between TCP header and original IP header. And then we create a tunnel. When we create tunnel, it means we took everything, this everything, this until here. This become our payload. Okay, and we inserted it into a new packet with new header. We added a new header over here, and then we insert ESP header between new and original IP header, and then here trailer and authentication data. Okay, if this is the case, now which fields are covered in authentication? Here. This is authenticated, huh?
Yeah.
And what is encrypted?
Same. Up to
Trailer.
speed there. Yeah.
This is encrypted. Okay, but here what we are doing, first authentication then encryption. But in this case, in the previous case, we are doing first encryption then authentication. So I can ask you in exam, how can we perform first encryption then authentication, or like this, huh? Interesting
Okay.
questions can come out of it. It is recorded and I will upload it. It will be in,
Okay.
it will be record become the part of record. Not good.
Yes.
It's Maghrib time. Yes,
Yes.
I think we can pray Maghrib and can come back after 15 minutes.
Okay.
Okay.